Okay, so now let's see. So we say it's a simple harmonic motion. So simple harmonic motion, it fulfills two conditions, which first one is it is a periodic motion. So what does it mean by periodic motion? Is as shown in the graph. All right, so it starts from the origins and then it goes up, and then when it reaches the maximum point, it goes back to the equilibrium positions again, and then it swings to the other side, the opposite direction, and then it reaches the maximum height or maximum positions, and then it goes back to the equilibrium positions. So it keep repeating the same process again, again, and again. Okay, so that's why we call it periodic motions. And then it fulfills the conditions where A is always proportional to negative x. So what does it mean by this negative? This negative means it's opposite direction. Okay, it's always opposite to A. So it actually indicates a direction. Okay, opposite direction. So A and X, they are always opposed to each other. Okay, they won't be moving in the same direction. So when an object getting further away from equilibrium position, A is either moving in the opposite direction with increasing acceleration, or it is moving in the same direction but with decreasing acceleration. Okay, that's why we have a negative sign here. So A always proportional to negative X. So it always have a negative relationship between them. Okay, either negative in terms of direction or either negative in terms of decelerations. Okay, so object could move in the same directions as X, but it decelerate, right? So that is how we identify whether an object moving with simple harmonic motions or not. Now, so based on this periodic motion, based on the graph given, we actually can form an equations that we can use to represent the displacements of the object, where x is equals to a sine omega t. So this is what I call general equation for simple harmonic motion. So whenever you have a simple harmonic motions, we can always refer to this equation. Okay, when you're given a graph of x against t, when you're given some informations of omega and so on, then it asks you to form general equations, then we always refer to this one. X equals to a sine omega t, where a is the maximum displacement, omega is the angular frequency. All right. Now, if if questions give you another types of graph, now equation is not always a sine equation. Sometimes you'll be given a cos function, where you have a graph where this object start from maximum position. All right. So where it start from maximum position, where it start from here. So if objects start from a maximum position, then obviously this is a cos graph. So in this case, the general equations we can use is x equals to a cos omega t. All right. So not always sine. Sometimes you will have a cos function, and sometimes questions will give you cos function as well. So what are you going to do? Then you just compare with the cos functions here. Okay, this is the general equation. Okay, we have two general equations, one in terms of sine and one in terms of cos, right? So of course, you can have another types of equations as well, where we call x equals to a sine, okay, bracket omega t plus phi. So where this phi is what we call initial phase angle. Okay, initial phase angle. Well, it tells you the object, it does not start from equilibrium position. If you use it with the sine function, all right, it starts with an angle. That's why you have initial phase angle. Now, don't get confused between initial phase angle and phase angle. All right, this whole thing, omega t plus phi, we call it phase angle. Okay, and then when it comes to a phi, okay, the symbol phi itself, then we call initial phase angle. So there's a slight difference between these two components. Okay, just make sure you know the name. All right, so this is the quick revisions on simple harmonic motions, on how to use the equations, and then how to identify whether an object undergoes simple harmonic motions or not. Okay, it's by looking at the relationship between A and X. So of course, when you have a general equation, x equals to a sine omega t or x equals to a cos omega t, there are two things that you need to know. Okay, well, first, a and omega, they are always a constant value. Okay, so A and omega, they are constant. Okay, and you can obtain it from the graph straight away, where A is the maximum displacement, okay, and omega, okay, omega is the angular frequency, where it can be calculated by using period. So from period, okay, you obtain omega. So omega equals to, okay, equals to what? Omega equals to, oops, okay, omega equals to 2 pi over t. Okay, so this is the relationship that you need to know. So information that can be obtained from the graph is A and period, capital letter T. So from there, you can calculate omega that can be used in your equations. Or from equations, you can calculate period that can be used in our graph, okay, in a graph sketching. So for a cost functions, also same, okay, you have A here, and then you have period right here. Right, so A and T, they are the quantity that can be obtained from the graph, and they are a constant. So why is it important to know whether they are constant or not? Because if it is constant, then you need to substitute it in the equation. If question asks you to form general equation based on the graph given, okay? So A and omega, the value you need to add it into the equation. If question asks you to find uh, general equations, form general equation for the graph given. Now, how about x and t? X changes with time, okay? So x changes with time means that it is not constant. Times also keep changing throughout the motion. It keep increasing, as you can see in the graph here, okay? It increase. So time is increasing, t increase. Now, small letter t and capital letter T, they are different. Small letter t, it refers any time, any moment. Capital letter T is the time taken to complete one oscillation. It is period. So don't get confused between capital letter T and small letter t. So small letter t, it keep increasing as the object's moving. Okay, so if it keep changing means that the x also keep changing. Therefore, x and t, we leave it as unknown in our general equation. Okay, so x and small letter t, these two quantity, these two variable, we leave it as unknown. All right, so we have a omega, and then we have x and small letter t. So now I give you 2 minutes to write it down. This is a quick revision on simple harmonic motion before we proceed to questions. All right, so you can write it down first. So 2 minutes for you to write it down, right? Okay, so now let us go back to the questions. So this is just a quick revision. If you want to know more, you can go through the videos on YouTube. So chapter 9, okay, 9.1, kinematics of simple harmonic motion. So kinematics means that we're going to look at how it moves. All right, we're going to focus more on the motion itself. So exercise 1, okay, exercise 1, the expressions for a displacement x of an object undergoing linear simple harmonic motion is given by this equation. So whenever you're given an equations in this form, all right, then you always compare with general equation. So which equations to use? All right, now which equations to use is very simple. You look at the equations given. Equations given is sine. then the general equations that we're going to use is in terms of sine, right? So if the questions give you in terms of cos, then the general equations we use in terms of cos, right? So jangan always confuse, okay, pasal cos and sine. So always refers to the questions given. Questions give you sine, then general equation x we use in terms of sine. So x equals to a sine omega t plus phi. Okay, your initial phase angle. So this is the general equation. So it doesn't matter whether the question asks you to do the comparisons or not. Whenever you are given an equations, you always compare it. Okay, you always do the comparisons because all information is being stored, is being given by the equations. So where x and t, they are measured in terms of cm, so be careful with the unit, and second respectively. So if x is in terms of cm, it means a is also in terms of cm, right? So the amplitude, the period, and the frequency of the oscillation. So questions ask you to identify these three pieces of information based on the equations given. So by comparison, what is the equations that we have? We have A is equals to 3.5 cm, right? Because question tells you x is in terms of cm, which means amplitude is also in terms of cm. And then it asks for period and frequency. Now, if you recall what I told you before, omega, period, and frequency, they are one big family. If you are given the information of any one of them, then you can find the other two. So by comparisons, we have omega equals to 8 pi radian per second. Okay, 8 pi radian per second. How do I know that it's 8 pi? Because by comparisons, if you compare these two equations, omega is in front of small letter t. Then look at the equations given. In front of small letter t, I have 8 pi. So this 8 pi is my omega. All right. So once I have omega, what can I do? I can then calculate frequency and period. Okay. Where omega is equals to 2 pi over capital letter T, and omega is also equals to 2 pi f. Right. So rearrange the equations, I can then obtain t is equals to 0.25 second, and then the frequency is equals to 4 hertz. Okay, 4 hertz. So this is a questions. This is the typical questions in chapter 9, where you are given an equation and then it asks you to identify all this information. Okay, so now I have A, which is 3.5 cm. I have period, which is 0.25 second, and I have frequency, which is 4 hertz. So I have all of the informations needed. Right. So the phase angles at times t equals to 0.02 second. Okay, 0.02 second. So what am I going to do right now? Okay, so whenever you are given a questions like this, basically you're just going to substitute the value into the equation. You are given t equals to 0.02 second. Now, if you look at the equations again, which part of the equations represent phase angle? Okay, oops. Which part of the equations represent phase angle? So this whole thing, okay, omega t plus phi. So I told you just now, okay, this whole thing, we call it phase angle, right? And the phi itself is the initial phase angle. But now since the question is asking for phase angle, so we want to use this whole part, omega t plus phi, right? So now we have omega t, which is 8 pi t plus 0.25 pi. Given t is equal to 0.02 second, so basically you just sub it into the equation. 8 pi 0.02 plus 0.25 pi. Okay, then if you solve it, eventually you will obtain 0.41 pi. Now the unit is radian, okay, because it's angle. So angle in terms of radian. Okay, so this is the answer for questions B. Now for question C, how are we going to solve it? The displacement at the instance mentioned above which means the displacement at t equals to 0.02 second. Okay. So what is the displacement at t equals to 0.02 second? Again, very simple. Since you're given the value, so what are you going to do? You just sub the value into the equation. So x equals to 3.5 sine 8 pi 0.02 plus 0.25 pi. Okay, then eventually you obtain 3.4 cm. So at times t equals to 0.02 second, the object is located at a displacement 3.4 cm from its equilibrium position. That is the meaning of this 3.4 cm. All right. So now I give you 1 minute to write it down, okay, to write down the solution before we proceed to the next question. Okay, so 1 minit untuk Anda catat sebelum kita proceed ke soalan seterusnya. Okay. So now let's see. Okay, let's go to the next questions. So what is the equation describing simple harmonic the motions of a mass on the end of a vertical spring which is stretched 8.8 cm from equilibrium positions and then released from rest and whose period is 0.66 second. So what is the displacement after 1.8 second? Now this question asks you what is the equations. Okay, it is asking for equation. And now what it tells you, now you stretch 8.8 cm from equilibrium positions and then release it, which means now your object is start from maximum displacement. All right, you release it from a maximum displacement. So, and the period given is 0.66 second. So this is the first part of the question. So what are we going to do in this question? So equations, you need equations, right? So equation, the general equations that we are going to use is x equals to a sine omega t plus phi. All right, this is the general equation. But then, are we going to use this equation? Now, if you look at this question, now you stretch a spring and then you release it. Now, you stretch it until 8.8 cm. Okay, the place where you release the object, that would be our maximum displacement. That would be our amplitude, which means now you release this object from the maximum displacement. All right. So in this case, the type of the graph that we are going to get, so this is x, and then this is t. Now you release object from 8.8 cm. So 8.8 would be our maximum displacement. You release it from rest, then it will start to oscillate. So basically, this is the types of the graph that we're going to get. And obviously, in this question, okay, the equations that we can use is actually cos. Okay, cos is easier to use. So if you don't know how to use this equation, if you don't know how to sketch the graph, of course you can stick to x equals to a sine omega t plus phi. But if you understand the question, you know that now you release the object from maximum displacement, which is from amplitude, you can straight away proceed to x equals to a cos omega t, okay, without initial phase angle. Because now you release the object from maximum displacement, straight away you can apply cos function. Okay, straight away you can apply the cos function. So what are we going to do now? Okay, what are we going to do now? If you look at these questions, okay, oh wow, wait, there's a mistake in my graph. So it say you stretch the vertical spring. If you stretch the vertical spring, then you won't be able to start from maximum, positive maximum. It should be negative 8.8. All right, so the graph would be like this. So you stretch. So this is a vertical spring, initial position. So this is after you stretch it. Okay, so what happened right now is object is located below initial position. So this one is your negative 8.8 cm. So objects start from negative position. So we have a negative cos function. So negative a cos omega t. All right. So you have a vertical spring, you stretch it 8.8 cm from equilibrium positions, and then you release it. So the graph that you're going to obtain is as shown on the right hand side. So how are we going to form equation? Based on the graph that I sketched, I know my A is equals to negative 8.8 cm. Okay, or I can just say 8.8 cm. Right? The negative is just for you to know how the shape looks like. So A is equals to 8.8 cm. And then you are given period T is equals to 0.66 second. But you know, in order to form an equations, you need omega. Okay, so we know omega is equals to 2 pi over t, which is then equals to 2 pi over 0.66. Okay, so from here, we know that omega is actually equals to 3 pi. Okay, 3 pi radian per second. So now that you have a and then you have omega, you can then form the equations. So x equals to negative 8.8 cos 3 pi t. So this is the equation, okay, where x is in terms of, okay, in terms of what? In terms of cm, and t is in second, okay? X is in cm, and then t is in second. So you need to state the quantity, the unit here. After you form the equation, you state, okay, they are in terms of cm and in terms of second. Because sometimes the questions will give you x in terms of meter and so on. So you need to state the unit in your final answer, okay, after you form the equations. Right? Remember to state the unit. Now, what if you want to use a sine function? Okay, if you want to use the sine function, then you have initial phase angle. All right, you have initial phase angle. So according to the graph given, okay, according to the diagram given, now your object start from negative maximum displacement. Okay, negative maximum displacement, which means your initial phase angle is equals to negative pi over 2 radian. All right. If you forgot how to determine the initial phase angle, then you go back to the lecture notes. Okay, kembali kepada lecture notes Anda. So lecture notes kuliah chapter 9. All right. So now your object start from negative A. So if negative A means you have negative initial phase angle. Why? Because it is a negative 90 degree, reverse 90 degree from equilibrium position. So this is 0. So it reverse negative pi over 2. All right, it reverse negative pi over 2. So therefore, we know initial phase angle for this question is negative pi over 2 radian. Now, of course, in order to know whether it is positive or negative, you need to be able to visualize the situation. All right, so how to visualize? The best idea is to sketch the graph or sketch the diagram. Okay, now obviously graph is better because graph show you your object start from maximum negative maximum displacement. So phi is negative pi over 2 radian. A is equals to 8.8 cm, and then omega, basically you just calculate it by using the same method. Omega is equals to 2 pi over t, which is equals to 3 pi radian per second. Okay, so combining these three quantity, if you're going to write your final answer in terms of sine function, that would be x equals to 8.8 sine 3 pi t minus pi over 2. Okay, and of course you need to state x is in cm and t is in second. All right, so this is your final answer. So I give you two answers. It's up to you which one you want to use. You want to use the one in terms of sine, or you want to use the one in terms of cos. Both are correct. Okay, both are accepted. Okay, now it asks you what is the displacement after 1.8 second. Now that you have the equation, you can straight away substitute 1.8 into the equations. So let's see, which equations am I going to use? Okay, I'm going to use the one in terms of sine. Okay, so x equals to 8.8 sine 3 pi 1.8 second minus pi over 2 radian. Okay, so remember, when it comes to chapter 9, the mode in your calculator should be in radian. Okay, so x is then equals to 2.72 cm. Right? So if you use cos, you will still be getting the same answer. Okay, you'll be getting the same answer. So x is equals to 2.27 cm. Okay, 2.27 cm. So I give you 2 minutes to write it down. Okay, 2 minit bagi anda catat. You guys can still hear my voice, right? Because my next door is doing renovation.
Can, madam.
All right, good. All right, so let's proceed to the next questions. A particle undergoes simple harmonic motions along a straight line, okay, and then completing 20 cycles in 2 seconds. Okay, now this phrase, it gives you a hidden information, right? So you complete 20 cycles in 2 seconds. Now, what is the information that you can get from this statement? Well, obviously it's period. 20 cycles, okay, 20 cycles, it takes 2 seconds. So what about one cycle? So this is the things that you need to know, all right? So from this statement, actually you are given the information about period. Okay, kamu diberi maklumat berkenaan dengan period. Because you're given 20 cycle 2 seconds, so 1 cycle equals to how many seconds? That is the things that you need to know. So the amplitude of the motion is 3 cm. So this is your A. And then at times t equals to 0, the particle is at its equilibrium position. Now, what is the functions of this statement? At times t equals to 0, the particle is at its equilibrium position. Well, actually, it tells you now you have something where the graph starts from its origin. Okay, so you have a graph that your object is actually start from origin. So you have a sine functions here. Okay, because your object start from origin. Okay, so determine the displacements to the right of O and its displacement to the right of O is considered to be positive. Write down an expression representing the displacement of the particles. So how are we going to determine the value? Okay, now this question actually is very simple now. First of all, you need to know we have general equation x equals to a sine omega t plus phi, right? So usually when we call general equations, usually we refer to this equation. So based on the statement in blue color that I highlighted in blue, at times t equals to 0, object is at its equilibrium position. This statement, other than it tells you your object starts from origin, actually it serves another purpose. It tells you how to determine the initial phase angle. So at times t equals to 0, right? T equals to 0, object is at equilibrium position, means your x is also equals to 0. Okay, your x is also equals to 0. So T0, x0. So substitute these two quantity into the equation. So you have 0 equals to a sine 0 plus phi. Rearrange the equation, you will find that phi is also equals to 0. Okay, which means object is now start from origin. Your initial phase angle is 0. All right. So the purpose of the statement that is being highlighted in blue, other than it tells you the shape of the graph, it also tells you how to determine initial phase angle. Now, object not always start from equilibrium position. Sometimes questions will tell you, at times t equals to 0, object is located at 2 cm from its equilibrium position. Then from there, you can then determine the initial phase angle of the object. Right? So ini cara, statement dalam blue color ini bukan sahaja bagi kamu graph, dia juga memberitahu Anda cara untuk tentukan initial phase angle. Okay, this is how we determine initial phase angle. Okay, so now that we confirm initial phase angle is 0, and then what else do we have? We are given A is equals to 3 cm. Okay, and then we want to find out what is the omega. Well, we don't have period, but we can calculate period based on the box that I showed you just now, okay, the one on the right hand side. 20 cycle is equals to 2 seconds. Then how about 1 cycle? Okay, so 20 cycle is 2 seconds. 1 cycle, let's see how are we going to calculate it. So 20 over 1 is equals to 2 seconds over x. All right. So x is equals to, okay, so what are we going to do? You divide it. Okay, how to divide it? You use 2 divided by 20. Okay, 2 divided by 20. So therefore, you're going to get 0.1 second. Okay, so this is actually your period. Okay, I'm going to change the symbol to make it easier for you. Okay, so the symbol is capital letter T. So period is 0.1 second. Okay, period is 0.1 second. So from here, we can then determine the omega. Now that you have A, you have a period. So from period, we know omega is equals to 2 pi over T. Okay, 2 pi over T, which is then equals to 20 pi radian per second. Okay, so now that you have omega, you have A, you have phi, you can then write down the equations. So the answer for questions A, x is equals to 3 sine 20 pi t. Okay, plus 0, you don't have to show it lah. Okay, so you just close the bracket. So where x is in cm and t is in second, right? X is in cm, t is in second. So that is the answer for questions A. Questions B. Okay, questions B. Determine the displacement of particles from from a O at times t equals to 1 over 16 second. So basically, you just sub it into the equation. So questions B, okay, now that you have the general equations, so x equals to 3 sine 20 pi times 1 over 16. Okay, therefore x is equals to negative 2.1 cm. Okay, negative 2.1 cm. So now from these questions, you can see the types of the questions that are always being asked in chapter 9. First, it asks you to form equation. So forming equation is a very important part in chapter 9. If you don't know how to form equations, then you wouldn't be able to solve the questions in chapter 9. All right. So from here, you can see how important, okay, how important it is to form equations. Okay, now let's look at questions number C. Okay, determine the times when particle is at x equals to 1.5 cm. Okay, it's at 1.5 cm. Actually, this question, it has more than one answer. All right, it has more than one answer. So let's see how am I going to solve it. Now you have x equals to 1.5 cm. Okay, so let's see. Question C. So given x is equals to positive 1.5 cm, so we have equation x equals to 3 sine 20 pi t. So we sub this 1.5 into the equation. All right, sub 1.5 into the equations. So 1.5 equals to 3 sine 20 pi t. Right, 3.5 sine 20 pi t. Rearrange the equations. You have sine 20 pi t equals to 0.5. Okay, equals to 0.5. Next step, okay, next, 20 pi t is equals to, now, for this question, okay, sine negative 1, okay, sine negative 1, 0.5, it will give you actually more than one answer. Okay, if you remember, we have a periodic motions here, which means the object will keep passing through 1.5 cm. Okay, so 20 pi t is then equals to pi over 3, that is the first value where you're going to obtain 1.5 cm. And then the second value, 5 pi over 3. The third value, 13 pi over 3. And then it keeps going on. Okay, it keeps going on. So this is a one, you will get a positive value. If you look at it in terms of degree, actually it is equals to 30 degree, 150 degree. This is where you get positive sign. Okay, and then the next value would be 390 degree. Okay, and then it keeps going on. Okay, it keeps going on. So you add another 120 is 5 and 10 degree and so on. Right? So this is a value that it will give you sine equals to 0.5. Okay, that will give you this value, a positive 0.5 after you signed it. Sine 30, sine 150, sine 390, sine 510, all of them will give you 0.5. Okay, so if you calculate it, you rearrange the equation, t is then equals to 1/60. That is the first answer. 5/60. 13/60, and so on. All right. So actually, you will obtain more than one answer, not just one answer as in given in the question. Okay. So most of the time, most of the times questions won't tell you how many answers you need to give. So in that case, you can give one. All right. For example, this question, you can just give one. Sometimes questions will ask you, state the first 3 times when the particle is at x equals to plus 1.5 cm. Then you have to show it as I shown you just now. Okay, as I did just now. So you need to calculate 3 different times where the object passes through 1.5 cm. Alright? So kadangkala kamu tengok soalan kalau satu markah sahaja, bermaksud Anda cuma kena bagi satu time. Okay? Kalau contohnya soalan ini, dia cuma suruh kamu kira soalan C, tapi dia bagi satu soalan 10 markah. So bermaksud Anda kena kira mungkin beberapa time. So Anda boleh tunjuk seperti yang saya tunjuk di sini. Or sometimes, soalan akan minta, bagi 3 masa, di mana X adalah plus 1.5 cm. Dan Anda kena buat yang saya tunjuk dalam video ini, dalam screen ini. So you calculate the possible angle first. You determine the possible angle first. So the possible angle is pi/3, 5 pi/3, 13 pi/3. So from here, you can then determine the time taken. Okay, so remember, it needs to be in radian if you want to rearrange the equations, if you want to simplify the equations. All right, so this is questions number 3 for you. Right, so I give you 5 minutes to write it down, especially question C. So make sure you understand this question. Okay, oops, boleh nampak tak? No, just now. I think here. All right, so 5 minutes for you to write it down. If there's anything that you don't understand, then you can ask. All right. So basically the sign y 30 degree and 150 degree, because if you remember, if you have 4 quadrant, for sine function, it is positive in the second quadrant and the first quadrant. All right, third quadrant and fourth quadrant will give you a negative value. That's why I just add 120 degree. Okay, positive 30 degree, and then the second quadrant 30 degree. So you have 30 degree, 150 degree, and then it jumps to 390 degree. Okay, so it skipped the third and fourth quadrant. Alright, sebab kamu ada 4 quadrant yang bagi kamu nilai positif, nilai 0.5 adalah second quadrant dengan first quadrant. Okay, so Anda basically can ignore the angle in third and fourth quadrant. So
Madam.
Sorry, write down. Yes.
I have a question.
Yeah.
Okay, what about the pi/3, then the 5 pi/3, the sequence? How do
you just convert it from a degree. Okay, if you leave your angle in degree, for example 30 degree, 50 degree, then you just do the unit conversion from degree to radian conversions. So we know 360 degree is equals to 2 pi radian. Okay, so then from here you determine 30 degree is equals to how many pi radian. So you do for every one of them. 30 degree, 150 degree, 390 degree, then you obtain the value in terms of pi. Okay, in terms of this one. So you do unit conversion. All right?
Isn't it pi/3 is actually equals to 60 degree?
60. Let me see, because the answer scheme gives pi/3. Let's do the unit conversions. So 360 over 30 equals to 2 pi over x. So I'm going to simplify it, 12, and then 2 pi. So rearrange it. I have x equals to 2 pi over 12. Then it should be pi over 6. Yeah. All right, it should be pi over 6.
So it's not pi/3, right?
Yeah, it's not pi over 3. Okay, the answer got a bit of a mistake. It should be over 6. Okay, so all of them should be over 6, right? Kamu sendiri buat pembetulan lah sini. Okay, the answer given here is wrong.
Yeah, everything should be over 6.
Okay, good. Thank you very much. So everything should be over 6. So how about the final answer? Is it correct? 20 pi t, so I will move it. Where's the- Okay, so everything here should be 120 if I'm not mistaken.
Yeah, madam, 120.
Okay. So this one should be 6. But the angle is correct, right? If you use a sine -1, is it equal to 30 degree? Help me check the angle for this step, whether it's correct or not, 30 degree. Yeah, calculator. I don't have calculator right now.
You mean the scene shift 0.5?
Yeah.
It is 30.
All right. Thank you very much. So here should be 6, 6, 6, 120, 120, 120. Thank you very much. Okay, so now I give you guys some times to write it down. All right, especially on how to solve a question C. Okay, give you guys 1 more minute to write it down. Try to understand the questions. Okay, and understand why question C got more than one questions because it's a periodic motions. All right. So let's look at one more questions. Okay, questions 4. A variable force acting on an object of mass 0.15 kg, so you are given mass in these questions, it causes the object undergoes linear simple harmonic motions. Figure shows how the force varies with the displacement x of the object for each cycles of oscillations. Determine the amplitude of a frequency. Okay, determines the amplitude of frequency. Determines the amplitude. Sorry, amplitude and frequency. So, what is the amplitude? If you look at this diagram, okay, the maximum displacement. So, positive displacement you have only 0.02. Negative displacements you have up until 0.2. So, which means the maximum displacements of the oscillation A is equals to 0.2 meter. All right, so you have a 0.2 and 0.02. This is actually the displacement. So you look at these two displacement, the greater value should be your amplitude. Okay, because the definitions of amplitude is maximum displacement. So A is equals to 0.2 meter. Now, how are we going to determine frequency then? So if you look at the questions now, you're given force. What can we do with force? Well, first we know F is equals to ma. And according to definitions in a simple harmonic motions, okay, A is equals to negative omega square x. Aha, so now you can see the relationship between force and our frequency. So you have omega. Well, always remember, omega, period, and frequency, they are one big family. If you have one of them, it means you can identify the other variables. So if you can identify the values of omega, then you will be able to determine the f. So f equals to m negative omega square x. So which equations, which values am I going to use? So I have a 0.15 kg. Now look at the graph again. Okay, graph gave me force 3 Newton. This 3 Newton happened at which length? 0.02 or 0.2? Now, obviously, it's 0.2. Okay, negative 0.2. So, this is the values that we are going to use in our equations. So, F is 3 Newton. Okay, it is equals to M is 0.15 kg. Now, it happens at, okay, negative omega square. I'm going to leave it. X, it happens at, this 3 Newton happens at x equals to negative 0.2. Okay, so I sub 0.2 here, negative 0.2. So rearrange the equations. I'm going to obtain omega equals to uh, square root 100. Okay, square root 100 radian per second. So omega, we know the relationship between omega and frequency. Well, remember, question is asking for frequency, so you don't stop at omega. So omega is also equals to 2 pi f. Combining these two informations, 2 pi f is then equals to square root 100. Rearrange equations, f is then equals to 1.6 hertz. Right? So this is the answer. So now we have the frequency, we have the amplitude. So remember, if you are given the graph, you try to locate the point, okay, where you can link the information from x component and y component together. So for these questions, obviously it happens at f equals to 3 and x equals to negative 0.2. That is the information that we can use in our equations. So when x equals to negative 0.2, f is equals to 3 Newton according to the graph. Okay, so cara kita guna graph, kita tengok titik mana yang kita boleh guna untuk dimasukkan dalam kita punya equation. Right? So that is the main point. That is the main positions that we're going to look at. So 2 minutes for you to write it down before we proceed to the next subtopic. Okay, 2 minutes for you to write it down before we proceed to the next subtopic. So next subtopic, basically we are just going to focus on one table. Okay. Okay, so questions 5, basically you can skip it. Okay, it just repeat the questions number 3. All right, questions 5. So if you have a space here, you want to retry the questions, of course you may. Okay, it would be good if you can retry it without referring to questions number 3. But basically it's the same as the questions number 3. Okay, just remember the answer here is wrong. Okay, this answer is wrong. Okay, so deriving equation, that is not in your lecture, that is in a tutorial. Okay, then we go through the derivations today. I'm going to go through the derivations quickly with you guys. Okay, I'm not going to spend too much time on the derivations because what you actually need to know is how to use the equations. Okay, derivation is not very important. It just gives you an idea on how to obtain the equations. So relations with times. Okay, now this is if you are given times and then questions ask you to determine velocity. Okay, so this is equations in terms of time. But sometimes questions will not give you times. Questions will ask you to determine velocity based on the displacement given. Okay, so for example, it tells you now your object is located at 5 cm from equilibrium position. What is the velocity? 5 cm, you don't have anything about the times. You don't have any information about the time. So you can use the equations in terms of displacement, which is the equation that we're going to derive right now. So first of all, how to get the equations of a velocity in terms of time? You differentiate the equations of x. So v equals to dx over dt. That is based on the definitions of velocity. Okay, so and we know x is equals to a sine omega t. So you differentiate a sine omega t, you then obtain v equals to a omega cos omega t. Okay, differentiate sine, you obtain cos. So if you're given now, let's say if you're given first equations in terms of cos, sometimes questions give you x equals to a cos omega t. If you are given a cos omega t, you then have to differentiate with respect to a cos omega t. So v equals to d over dt, a cos omega t. A has nothing to do with time, therefore you can take it out first. So you differentiate cos. Okay, you differentiate cos. So differentiate cos, it will give you sine, okay? And then omega, you take it out. So you have a omega sine omega t, right? This is if questions give you in terms of cos. So when you do differentiations, when you want to write equations for velocity, you have to be extra careful with the sine and the cos. Okay, so if your x is given in terms of sine, then v is in terms of cos. If your x is in terms of cos, then the v is in terms of sine. Okay, it's in terms of sine. It should be negative sine. You differentiate cos, you get negative sine. Okay, so cos, basically the relationship is like this. From cos, you differentiate it, you obtain sine. From sine first. We're going to start from sine. Sine, you differentiate it, you obtain cos. Okay, you differentiate sine, it gives you cos. You differentiate cos, it gives you negative sine. Okay, it gives you negative sine. You differentiate negative sine, it just go back to negative cos. All right, so basically this is what happens. So okay, we are done with differentiations. Just have to be extra careful. If you have sine, then v is in terms of cos. If you have x in terms of cos, then your v would be in terms of sine, negative sine. Okay, now let's go back to the derivations. Relation with displacement x. So a is equals to, not a, v. V is equals to a cos omega t. That is the equations that we have. Okay, v is equals to a omega cos omega t. So what am I going to do now? I want to rearrange the equation first. So I rearrange until I obtain cos. So cos omega t is then equals to v over a omega. Okay, so this is the first equations. Second equations, what I have x equals to a sine omega t, right? And then I rearrange the equation. Becomes sine omega t equals to x over a. So the reasons why I use these two different information, two different equations is because if you look at the equations one, there's nothing to do with x. Okay, it has nothing to do with x. There's no equations involve x. So what am I going to do? I need to link it with x. So I use x equals to a sine omega t. I rearrange it and I obtain sine omega t equals to x over a. Now I have these two equations. What am I going to do? I'm going to link these two equations, cos and sine together. But how am I going to link them together? By using trigo identity. Okay, so we know cos, cos, not con. Okay, cos square theta plus sine square theta equals to 1. So this is the only equations that we can use to link the two of them together. Okay, so cos square theta plus sine square theta equals to 1. This is based on trigo identity. So now I have cos omega t. So cos square omega t plus sine square omega t equals to 1. Okay, and then what happened? All right. I'm going to rearrange the equations. Okay, because I want v on the left hand side, so I will leave cos on the left hand side. So cos omega t is then equals to 1 minus sine square omega t. Okay, so cos omega t is then equals to square root 1 minus sine square omega t. Now sine square, okay, what am I going to do right now? So I have, okay, here cos omega t, I have v over a omega. So square root 1 minus x over a square. Okay, x over a square. So rearrange the equations. Why am I going to write it? Okay, I'm going to write it here. So rearrange the equations. I then obtain v equals to a omega square root. Now, because it is a square root, actually it should have a plus minus sign. Okay, so plus minus a omega 1 minus x square over a square. All right. So because I have a inside the square root and a outside the square root, so what am I going to do next? I'm going to move this a into the square root. But how? So v is then equals to plus minus omega square root. Okay, if you move a into the square root, it will become a square. So a square 1 minus x square over a square. Okay, so you multiply into the bracket, you will then obtain v is equals to plus minus omega square root a square minus x square. So this is the equation in terms of displacement. So if questions now tells you your object is located at 5 cm from equilibrium, determine the velocity, then you use this equation. Okay, then you use this equation. So x is equals v is equals to plus minus omega square root a square minus x square. All right. So I give you 2 minutes to write down the derivation. So this is the hardest derivation. Okay, the rest is very simple. So this one I give you more time to write it down. Okay, saya bagi kamu extra masa untuk tulis dia. Okay, ini yang paling susah. So if you can understand this one, then the rest should be very simple. So relationship between v and x, you start from equations for v and then you do for the equations for x. Okay, so 1 more minute for you to write it down. So remember, you have relation with times and also relations with x. Okay. Okay, now acceleration, same things. Okay, so from the definitions of instantaneous accelerations, A is equals to dv over dt. Therefore, you differentiate v. So v from previous, okay, from here, we have it in terms of cos. So if you derive it in terms of cos, then you're going to obtain sine for A. Okay, but if you derive it in terms of a sine, for example, now I have A equals to d over dt. Now, just now, based on the previous questions, I told you, if I have x in terms of cos, then my v is in terms of negative sine. Okay, so I'm going to derive negative sine here. So negative a omega sine omega t. All right. So if I derive it, what am I going to get? Now, negative a omega have nothing to do with time. So I can take it out. So it is equals to negative a omega d over dt. Then you just differentiate sine. Okay. So differentiate sine omega t, it will give you an omega in front of the cos. So it is equals to negative a omega. Now differentiate sine, it gives you omega cos omega t. Okay, therefore it is equals to negative a omega square cos omega t. This is if you are given equations x in terms of cos. All right. So from here, you will then obtain a in terms of cos as well. So negative a omega square cos omega t. So the maximum accelerations a, okay, occurs when sine omega t is equals to -1. Therefore, a max is equals to a omega square. So this is the equations for maximum acceleration. Okay, the equations for maximum accelerations. Now let's see how are we going to derive it. So we have a equals to negative a omega square sine omega t. So again, I want to remove t, so I rearrange the equations. Sine omega t is equals to negative a over a omega square. All right, so this is my first equation. Now I want to relate with x. Therefore, I'm going to go back to the equation for x. So x equals to a sine omega t. Okay, so rearrange the equations. Sine omega t is equals to x over a. So this is my second equation. Now, first equations, I have sine omega t. Second equations, I have sine omega t, which means I can use relationship 1 equals to 2. So from here, I have negative a over a omega square equals to x over a. Rearrange equations, I then obtain a equals to negative omega square x. So this is the equations that we have seen before, okay, in the definition. So a is equals to negative omega square x. This is how we obtain the equations in the definitions of simple harmonic motion. Okay. So done. Okay, basically that is the definition for accelerations. Very simple. Okay, very simple. Now sometimes you can even do it in a simpler, more simple way. So if you look at these two equations, x equals to a sine omega t. If you look at equations for a equals to negative a omega square a omega square sine omega t. So you have a and sine omega t here. So basically you can straight away substitute x into the equation. Okay, kalau nak lagi senang punya, anda terus substitute x ke dalam equations A. Boleh juga. Okay, Just that I'm using this method, equations 1 and equations 2 method, to shows you how we link, okay, A and X together by using the method that's same as the previous scenario. Okay, kita guna ini equations 1 and equations 2 because we want to link V and X together. So now we use equations 1 and equations 2 again because I want to link A and X together. Okay, I want to link A and X together. So again, I give you 2 minutes to write it down. Okay, you can write down both, the one for the differentiations and also the one for the derivations. Okay, boleh catat kedua-dua. So 2 minutes for you to write down both. Okay, so let's move to next section. So we have 3 more derivations to go. Okay, so potential energy. So potential energy, consider the oscillations of a spring as a simple harmonic motions. Hence, the potential energy for the spring is given by now. With U equals to 1 over 2kx. Now, this equation is opposite. This table is opposite to the page before. Okay, now you have a displacement, relation with displacement first. And then we want to derive the equations for potential energy in terms of time and also in terms of a kinetic energy in terms of time. All right. So previously we have equations in terms of time, then we derive it for displacement. Now we have equations in displacement and we want to derive it for the equations with time. So U is equals to 1 over 2kx, that is the energy stored in spring, and then K is equals to m omega squared. Okay, K is equals to m omega squared. Sub it into the equations, you have U equals to 1 over 2m omega squared x squared. So if you are given displacement, question asks you to calculate potential energy, then you apply these equations. So what if the questions want you to calculate the potential energy if you are given time? So now let's see. We have U equals to 1 over 2 m omega squared x squared. And then we know x is equals to a sine omega t. Okay, a sine omega t. So you sub these equations into U. Okay, you sub x. So sub x into U, then you will obtain U is equals to 1 over 2m omega square a square sine square omega t. Okay, a square sine square omega t. So this is the equation. All right, this is the equation. If the question asks you to determine potential energy in terms of time, right, in terms of time. So if you are given times, questions ask you to determine potential energy, then this is the equations. And then same things, same we're going to do it for a kinetic energy, all right? So the kinetic energy of of object in simple harmonic motion is K equals to 1 over 2 mv square. If you want to calculate in terms of displacement, you sub V equals to omega square root a square minus x square. Okay, so you don't have to include plus minus because kinetic energy has no direction. You just want the magnitude. So you sub it into the equation. So K is equals to 1 over 2 m omega square a square minus x square. This is if you are given displacement. Now, how about time? So we have K equals to 1 over 2 mv square. Okay, K equals to 1 over 2 mv square. So what are we going to do? Now we know V is equals to A omega, oops, so far away. So equals to A omega cos omega t, right? Then we have K is equals to 1 over 2 m. Now, V square, so you have A square omega square cos square omega t, right? So m A square omega square cos square omega t. So this is the equations for K in terms of time, okay, with relations of with the time, okay, relation of time. So sometimes, okay, if you don't have the equations or if you don't have the information for m omega, so remember, uh, okay, remember you have a K is equals to m omega square. Okay, K is equals to m omega square, in which it means these two equations actually can be written as U equals to 1 over 2 Ka square sine square omega t. Okay, Ka square sine square omega t. Whereas for K, it can be written as 1 over 2 Ka square cos square omega t, where K is a spring constant. Okay, K is a spring constant. So you have two equations. One is in terms of m omega square and one in terms of K. Alright, so kamu ada dua equations. Alright, so done. Okay, we're done for potentials energy and also the kinetic energy. Okay, potentials energy done, kinetic energy done. I give you 1 minute to write it down. This is very simple. All right, this is very simple. Okay, so the last part is the total energy. Total energy, basically, you just add them up. Okay, and again, this total energy, the idea is same as your conservations of energy. All right, where the total energy is always conserved. Okay, always constant in a closed system. So constant in a closed system where E equals to K plus U equals to a constant value. Okay, a constant value. So based on the equations above, we have E equals to K plus U, where K is a 1 over 2 m omega square bracket A square minus x square, and then this is your U. Okay, so when you add them up, you will obtain E is equals to 1 over 2 m omega square A square, where K is equals to m omega square, therefore E is equals to 1 over 2 Ka square. Now, based on these two equations, what can you say about the total energy? Well, total energy, it does not depend on X, it does not depend on T. Okay, so it does not depends on x or t. Therefore, you cannot find x and t in the equations. So basically, if the question asks you to calculate total energy, straight away you can get the value if you are given the amplitude. All right, if you're given the amplitude. So it's very simple. You don't have to search for the x, you don't have to search for t. There's no equation in a sine or cos function. All right, so basically you just have a one equation for total energy, which is a constant value. Okay, which is a constant value. Okay, so I think we are done. Okay, so remember, actually, all of this derivation, you can refer to the notes, to the lecture notes. Okay, the table given in the lecture note is sum up everything. It's some of the equations that we derived just now. Okay, wait, yeah. Oh, the table is missing. Okay, so actually it should have a table here. All right, now I'm going to give you the table. Since it's not given in your notes, I'm going to give you the table, you write it down. Buku kamu tak ada jadual kan? Hello? Ada atau tiada?
Tak ada, madam.
Tak ada. Okay, so kalau tak ada, anda sendiri kena buat table. So this is a very good summary table. Okay, so we need a 4 column. Okay, 4 column, one. Here, this is small one. And 2 more here. Okay. So this is the relation. And then this is the maximum value. This is relations with t, relations with x. Okay, so the first one, we have a variable x. So the maximum displacement, we call it a. Okay, so in terms of time, straight away x is equals to a sine omega t. Now with x, of course, straight away is equals to x, okay, because x itself is a displacement. You don't have to derive any new equations for it. So the next one is v. Maximum value for v, okay, v max, we have a omega. So this is the maximum value that we have in our graph. With time, we have v equals to a omega cos omega t. Okay, so all these equations, we assume our x is in terms of sine. So v is then equals to plus minus omega square root a square minus x square. This is with time, right? And then we have a. So a maximum, we have a omega square. Okay, and then with time, a is equals to negative a omega square sine omega t. And the relationship with displacement is a equals to negative omega square x. Okay, negative omega square x. And then the next one, we are going to look at it in terms of K, kinetic energy. So K, we don't have a maximum value. Maximum is just simply equals to your energy, total energy. Okay, so K in terms of time is a K equals to 1 over 2 m omega square x, a omega square cos square omega t. With relations of x, k is equals to 1 over m omega square a square minus x square, right? And then for the next one, we have potential energy, no negative value again. So U is equals to 1 over 2 m omega square a omega square sine square omega t. Okay, and then U is equals to 1 over 2 m omega square x square. And then the last one we have E. Okay, so no such thing called maximum value because it's constant value. So we don't have it. Okay, we don't have equations with time. What we have, okay, we also don't have with x. But then I'm just going to write it here. E is equals to 1 over 2 m omega squared a squared, or 1 over 2 ka squared. Okay, so this is a summary table. So basically this subtopic is all about this equation. Okay, it's all about this table. So as long as you can understand this table, you know how to use them, basically we are done with a second subtopic. Okay, we are done with this subtopic. Not second subtopic, first subtopic, but in terms of the times and also the displacement, the motions, the kinematics, right? So now, okay, I give you some time to write it down. Once you are done, that's all for today. Okay, now since tomorrow is holiday, okay, tomorrow is holiday, we don't have class tomorrow. What am I going to do? I will give you a revisions number 3. All right, so we are done with revisions 1, revision 2. I will give you a revision set number 3. So you do a revision set number 3. And then for this Saturday we have a replacement again, right? So for this Saturday, I'm going to do meet with you guys. Okay, we'll replace the class on Saturday. So Saturday class, I bring it forward. I bring it to the tomorrow. So basically, I'm just going to replace it with a revision set questions. So Saturday, we will have a mid section. Okay. So I think that's all for today.